And to keep the things interesting, we now move on to the next session of the day, the panel discussion. This discussion will bring together leaders from academia, research, and industry to share their insights on structural strengthening and seismic resilience in practice. Let me take a moment to introduce our distinguished panelists. Our first panelist, Mr. Amandeep Garg, is Managing Director, Creative Design Consultants and Engineering Private Limited, with extensive experience in structural design, code development, and consultancy for major infrastructure projects across India. He has contributed to several Indian standards, including IS 1893 and IS 456, and has been instrumental in advancing design practices for seismic safety. Our second panelist, Mr. Pradeep Garg, Chief Engineer, Central Vista Project, CPWD, and Chairman, Indian Concrete Institute, Delhi Center, has led iconic projects such as the Signature Bridge, Supreme Court Museum, and several national infrastructure developments, while contributing to key BIS and IRC committees. The third panelist, Mr. Manish Jain, Technical Director and Head of Structural Department, ACOM. With over 21 years of experience in India and abroad, he has led structural design and execution for large-scale projects across aviation, power, and infrastructure sectors, with a strong focus on sustainability and digital transformation. Dr. Vasant Matsagar, Dogra Chair, Professor, Department of Civil Engineering, IIT Delhi, and Advisory Board Member, Seismic Academy. A leading researcher in earthquake engineering, Professor Matsagar has authored over 100 international publications, holds patents, and actively contributes to BIS and IRC code committees, is our final panelist. And to steer this discussion, we have our moderator, Mr. Shaunak Mitra, Head Codes and Approvals, Hilti India, and a core member of the Seismic Academy. Please join me in welcoming our panelist and moderator for this engaging discussion. Over to you, Mr. Shaunak.
Thank you. Thank you, Divyani, and warm welcome to everyone, and warm welcome to all the panelists. Since the morning, we have had a lot of discussions and deliberations centered around the construction practices, centered around the codal developments, some research work we understood, some projects that have been taken up nationally by CBRI. We understood that practical applications of active and passive control devices of earthquake resistance, we have all gone through that. It's time that we translate and take all the discussions a little more practical oriented, how that translates to job sites and the real-time practices. And for that, I will start with the first discussion and my question to Mr. Pradeep Garg. Sir, we know that we have been discussing the theme is also around building retrofits. And we have seen earlier there was a handbook by CPWD that was developed around repair, rehabilitation, and retrofit. And if I'm not wrong, that was the first of its kind content that was developed, which is still referred. So with the changing framework, with the changing guidelines that is happening, the extensive codal revisions which are coming up, and the technology enhancements, do we also look forward to such documents, development of such document being released by CPWD, yours being a pioneer organization, and in fact, the best construction practices follow the CPWD regulations. So any thought around that?
Shaunak, if you're talking of that, we call it handbook on repair and rehabilitation, which is in public domain, released by CPWD. The first edition was somewhere in 2006 by Dr. A.K. Sharma, is one well-known person in Delhi community. And then it was subsequently upgraded or revised in 2012 or something. And then since then it had not been updated, so 10, 12 years. But if you go into that manual or a handbook, it is very much relevant today also. In fact, in the last 10 days back only, we were talking on the same handbook. See, anything, if I think of RCC, I will start with cement, I will start with aggregates, the testing methodologies, and those elements, unless I get on those elementary, I will not be able to do a high performance concrete or maybe ultra high performance concrete. Same applies for this handbook also. So this handbook actually gives you very elementary knowledge how to, in fact, I remember we are, Amandeep ji, Bhaumik ji, we are developing a code on service code on structural audit and retrofitting. So we start with the examination, preliminary examination, visual examination, then we go into detailed examination, and then in each step what I need to do, what I need to do. Those things are already mentioned in that book, and it is so relevant. In fact, in my one of the projects, Center Vista project, we had some problem. So some 2 months back. So when I wanted to get into details, I referred that one book. And then I read through that, I took some 1 day to read that, and I found whatever we are talking in our codal drafting course is still there, is already there in that book. So yes, but at the same time, the new technologies and new material, like we have fibers, so many fibers, so many anchor technologies. Anchors is already there, by the way, in that booklet. So those things need to be incorporated, and now we in CPWD are, because that booklet was developed 100% CPWD by in-house. Now we are thinking in a direction that CPWD with experts from different domains. We in fact see in the hall so many experts sitting. So maybe a team of people will work on it to update it.
Fair. Thank you, sir, for the perspective. And you touch based upon one of the standards that you're working on with respect to the structural audit and retrofitting. And you mentioned Amandeep sir, Bhaumik sir, you are jointly working on this. Could you just share a little bit of an insight, you, Amandeep sir, together, can you share a little bit of an insight on what is expected out of it?
Well, Shaunak, this standard, what we are talking is about the process of the structural audit. How a building or a structure should be assessed. As first condition would be that what is the condition of the building. So condition assessment of the building is first considered as the structural audit part. If the condition is not good, then we have to go to detail. Now, when we go to detail, we may have to do some testing. This testing may involve some non-destructive testing, some semi-destructive testing, and in some time, at some projects, probably you will have to dig to get the assessment of the foundations also. So the code will guide the professionals how to go about the assessment of a structural system or building or any kind of structure.
May I add on it what Amandeep said? In this code, in addition to that, see, one of the biggest problem, like I'm from field side, we face is not about engineering part. We have excellent engineers there. The problem comes in procedural systems. So when it comes to retrofit, repair retrofitting and the structural audit, there's a process involved, which says that I have to appoint an X agency, then what should be the parameters for assessment of eligibility, then what is the role of that agency, and what should be expectations. So those kind of parameters are being covered in this code, so that anybody who is not from this field of repair rehabilitation, so they will have some 20-page booklet. There they will get the comprehensive guidelines. If I have to get this work executed, what all he needs to do. So this is what this code is going to help upon.
Sir, at the same time, we also see NBC getting revised, the entire framework of IS 1893, 13935, everything getting revised. And in the chapter on administration, there is also some quick mentions on the aspects of how the buildings have to be retrofitted, how the structural audit has to be done. So my question to Manish sir here is, I mean, there are some guidelines. So how do you see this translating to building owners? Because not every structure is industrial structure or infrastructure projects, but a large section of it is building projects. So how do you see that translating with building owners at the end of the day? How the adoption will be?
So Shaunak, see, for building audit purposes, local authorities like BMC and DMC, these guidelines, they guide the developer, builder, how the auditing has to happen, right? So NBC is more of, kind of a recommendation which is giving that earlier it was like 30 year. After 30 year, you have to get the stability certificate done, and then obviously it is getting changed now. So now the requirement is that after 10 years, like it is preponed to 10 years, and after 10 years, after every 5 years, you have to get the certification done. So this will obviously get translated into your BMC and DMC guidelines, and eventually it will have obviously better focus from the developers, because it is not a long-term goal now, right? So if you are building a building now, and within 10 years, you'll be able to, like, you'll again have to go for a stability certificate, right? So I see from that perspective that the material selection would improve definitely, and now there is a better focus on the quality. because the developer is still there, and code is kind of giving the onus to the developers also that they have to maintain the building in such a shape that it can withstand, right? The only problem with structural audit is, there are developers who are kind of little bit misusing it. How it is? Because our Indian codes keeps on changing, right? There were many buildings which were built in 2008 or 9 in NCR region, right? And they were basically designed basis 2002 code, right? 1893-2002. And now after 10 or 15 years, these buildings are available for lease, right? And we are like being consultant, we know that a client comes up and say that by 2016 there's a new code, and can you prove that this building withstand that requirement? And that is where the problem begins, because these buildings are kind of already in use. You cannot have kind of intrusive measures to improve the the requirements of the building. So that creates the little problem. Structural auditing part is basically you have to identify the stresses, distresses in the building, and you have to point specific solution has to be given, right? So it should not become a tool to improve the building, in a sense that we are using revised codes to translate that. So that's one concern I have.
Sir, in 2023, if I remember correctly, there was also a ruling by the Delhi High Court that all buildings which are above 20 years, specifically hospital buildings, they have to be also strengthened and retrofitted. In this regard, aside hospitals, how do you also rate the overall preparedness of buildings in NCR, since we are sitting in NCR, for future earthquakes, or what is the way forward? And this is open to all the panelists.
Okay, the question is related to the hospital buildings. Today morning we have heard Dr. Agostino Marioni talking about how important it is for the hospital buildings to have one of the technologies for seismic response control, which is base isolation. But in particular, what he had highlighted is in other parts of the world, and particularly in Turkey, in the few years back there was one significant earthquake. And most of the hospital buildings which survived, they were all base isolated. Whereas, for example, the Iskander Hospital there, it completely was collapsed during that earthquake, and we can imagine what kind of catastrophe it has brought. If we talk about Indian context, during the 2001 Bhuj earthquake, all of us are aware that Bhuj Hospital building was collapsed. And after that, there was a lot of talk that particularly for the hospital buildings, in order to achieve the seismic performance level, and I will talk about that as we go along, we need to have the base isolation incorporated. However, after that, again, hardly any hospital buildings are built with base isolation. If we see some of the new hospitals in government sector, at least there is some thought going into having introduced base isolation in there, in order to achieve the operational level performance, not immediate occupancy level performance. I will also talk about the multiple hazards, but another aspect is for the existing hospital buildings. Again, there are seismic retrofitting techniques available, as well as seismic strengthening techniques available, typically for hospital buildings. In order to achieve the operational level of performance, seismic intervention is required in such a level that from the life safety level, their performance is brought to the operational level. And once again, the same technology of base isolation gives us that opportunity. For the existing hospital buildings, we can retrofit them to achieve the operational level of performance.
And sir, you touch based upon the multi-hazard aspect. Just a follow-up questions, and then we come to the other panelists. That in areas like Uttarakhand, there are so many incidents that we see over the last few years. So is there any specific approach or specific guideline that we can look forward to address all this, or is something already in development?
Yeah, so that is where I would take a little bit of a more time so that we little go back, see as to what is the need of having our infrastructure built multi-hazard resilient, and particularly our communities, multi-hazard resilient communities. And for that purpose, we need to ensure that all our built infrastructure performs in a way that we want. Now, there is a skepticism and there is a criticism also that we cannot design and build our structures with more than one extreme event happening simultaneously. Our current assumptions made in the code is that no two extreme events happen simultaneously, and thereby, if we try to design our structures for more than one extreme event happening simultaneously, either that is completely infeasible, or we will end up having highly uneconomical design of the structure. However, in the literature that has been produced from IIT Delhi, what we have mentioned is that very premise of designing the life safety level of structures which are code compliant against multiple hazard is not the premise with which this argument is being given. The way we are proposing this design for multi-hazard is that we go to the performance-based engineering. We decide for a given structure what kind of performance is expected when one extreme event happens, when more than one extreme event happens, depending on their probability of occurrence. One extreme event may happen with certain probability, and for that, depending on your functional requirement, you design the structure. It could be operational level, it could be immediate occupancy, it could be life safety, or it could be collapse prevention. Typically, in India, so far, we have not been following performance-based design. Alok Bhaumij is sitting here in Civil Engineering Division Committee of 39. We have discussed quite significantly on this aspect of introducing performance-based seismic design in our IS 1893. However, as of now, we are yet to adopt it. In absence of that, with the current code provisions, I can take examples of IS 456 or IS 800 for concrete or steel structure design respectively. If we design as per these codes, the performance that we achieve for the structures is the life safety. It's not either immediate occupancy nor the collapse prevention. If we introduce the concept of performance-based engineering, and particularly performance-based seismic design, then we decide as to what performance we want under which extreme event, whether that extreme event is earthquake or flood, as you have mentioned, or because of the wind loading, because of the anthropogenic extreme events such as fire or explosion happening in oxygen plant. All these are different events with their different probability of occurrence, and not in each one of them we would like to achieve, for example, life safety performance. In some cases, if the occurrence of earthquake is too frequent, particularly in the Himalayan, trans-Himalayan region, then we may expect that our structure should perform as operational level, particularly the hospital buildings. Whereas in those areas, if, for example, wind loading is not a governing criteria, we may design those structures using the multi-hazard principles for the lowest probability of occurrence of failure under wind hazard for life safety performance level. Thereby, that economy is still achieved, but we are making sure as a structural engineer that our structure is not collapsing in any one of those extreme events. Right now, I'm skipping the discussion related to cascading hazards, concurrent hazards. I'm only talking about non-concurrent, non-cascading hazards, which I have addressed your question in specific under the multi-hazard design, which is performance-based, which is based on the probability of occurrence of the two events. So it is still feasible. We have started this activity in 2009. There is a laboratory specific multi-hazard protective structures laboratory at IIT Delhi, where we have put forth a design recommendation for civil infrastructure, and we have published that in the literature. We have again showcased this to the codes and standards committees. As of now, Bureau of Indian Standard is yet to take into account in this code, IS 1893. However, in the National Building Code, it has already been adopted. There is a specific chapter in National Building Code NBC which talks particularly about the multiple hazard designs and what are the different districts in country which are experiencing multiple hazards and how we have to design for that. However, we have not come to the level where there are some specific design guidelines. If I talk about the Indian Roads Congress, IRC, there is a B2 committee, there is one subcommittee formed there, which is looking into development of some code specifications for bridge infrastructures under the multiple hazards.
Thank you so much, sir. And maybe to the other panelists also, I open up that question about the level of preparedness of our buildings and how do you rate that, the safety going forward against earthquakes, and any recommendations in this regard. To maybe we start with Amandeep sir. And
well, it's a very pertinent question to be discussed here, that how prepared we are in terms of the current infrastructure availability and for the buildings which are yet to come, or the other structures which are yet to come. As Dr. Matsagar just suggested, that we should have a system of performance-based design in which we should be considering the multiple hazards and as per the probabilities, and also probably in very near future we would be having guidelines for the upcoming buildings or upcoming structures. But if I see the existing infrastructure, existing built environment, we have yet to do a lot of things. Now, what we see, the infrastructure which was created 30, 40, 50 years back, or even 10, 15 years back, we see a lot of issues in the buildings because of 2-3 reasons. One could be the not up to the mark construction quality, and other could be not up to the mark maintenance. Now, because if the quality was not up to the mark and maintenance is also not up to the mark, then the deterioration of the existing buildings or the structures is at a faster pace. What at the time of maybe 1978, IS 456 was when developed, the assumptions were different, and then in 2000 when it came, probably the durability took some more weightage, and some details were added into IS 456 for the durability. Till I see if the building was constructed in 2010 or maybe 15 also, we see a lot of issues in the existing built environment. Now we have to do a lot of focused work together to make our existing built environment safer at one place, and whatever we are going to construct in near future, we have to consider whatever best practices, whatever best materials, whatever best engineering principles we can use, we have to apply all together. Our Indian standards give us a minimum benchmarking that at least this much has to be taken care, but as we are developing and going to be a developed nation in another 20-25 years, we have to be very, very serious about what best we can do beyond our minimum requirements.
Yeah. Maybe Pradeep sir, you can just add your perspective.
I'll take you to a very different perspective, adding to what Amandeep ji said. See, I am from field, so we look into from construction education point of view. So when it comes to building health, maintenance, we basically face two problems. One is my psychological or my mindset. I will pay best of my attention for construction, but when it comes to the maintenance or upkeep of it, I am I will be neglecting because of my mindset as well as because of financial reasons. So that becomes my first point of inertia. As I said in the beginning also, we are having an excellent engineers, we are having excellent literature, knowledge, but when it comes to implementation of it, first the client is now ready to take up the maintenance part of it and to look into the building health. That becomes the first stumbling block. So that is a social change we need to bring upon it. Second is for us engineers, like when I graduated in say 90s something, so or till date in fact, our curriculums are being taught for new constructions. I can challenge, even in current curriculums, we students are not being trained to look into the building when it is in the functional state. And the construction period is only 2 to 3 years. The life of the building is 80 years, 90 years. So that perspective, if we start bringing that kind of psyche and knowledge into our professionals and including our users, we can, whatever engineering we develop, we will be failing at it. And to give you a very simple example, I give you an example of last month only. In fact, Rohit is sitting here. So I belong to Jaipur. So my uncle called me. He has a very nice bungalow in a prominent area, which was constructed some 40 years back. And a nice bungalow covered with all false ceiling, everything like this. So I don't know, for some reason, he took out the false ceiling. When he took out the false ceiling, he saw the condition of the structure, the corrosion and spalling and everything what we keep on discussing, it was visible in a small 10 meter by 10 meter space. Now he realized that this problem cannot be solved by an architect. So he called me from there. When are you coming to Jaipur next time? Please have a look at my. I went to it, I saw it. The solution, we all know it. No big deal. What is the problem, how to solve, we all know. The problem which I faced was, I could not find 2 proper workers to handle to that area. I know what to do, I know what material to get, engineers I know it, but because the workers are trained to do the plaster, the workers are trained to do the RCC work, they are not trained and they don't know how to take out that concrete, spall concrete or reinforcement, how to do a treatment. So we have to bring that kind of professional change both at engineers level as well as at skill level, worker level. Unless we do it, we'll be actually not gaining the kind of results we are looking forward in India. And my sites are hardly 2 or 5 kilometers here. The biggest challenge we face presently is workforce. Getting 100 people at project site. Right now my site is going on. We got 500 workers working. I am short of 100 people. Getting to 100 people is the biggest challenge than any engineering challenge for me. So that's where we also have to look into it.
Sir, rightly pointed out by you, but I think one more facade I want to touch upon, like IS 1893 2002 was there, right? And then 2016 came. There was substantial increase in the base shear forces we noticed, right? And we also run some number on 2023 also, and there's I would say that still there's a lot of numbers are coming up. So from that perspective, there is a high demand in the base shear is going to come. So now in the morning also we discussed that macrojonation, microjonation, the site-specific spectra we need to develop for our country also, so that we do not, at least we can save on those base shear numbers and we can invest that money into detailing out the building in a much better manner that performs better in seismic event.
Well, I would add to that, as rightly pointed out, few more perspectives. And though, of course, the challenge of skilled manpower is there, nobody can deny it, and we have to do something for it. We just can't say that we are not getting adequate manpower. We have to skill the manpower. We have to make programs for the capacity development and whatnot. And many organizations are doing that also. The only thing is that we should now demand the certified or skilled manpower. And if we'll start asking this thing, then probably there will be demand for training and people will go for training. In fact, from our side also, in our organization also, we are trying to get into it and try to skill people. At this moment, we are more focused on skilling the engineers for the structural audit and retrofitting remediation point of view, because as Pradeep ji rightly said that in our engineering curriculum, we are just seeing the new construction and we do not have any consideration about the existing built environment. And more thing, that engineers also think that whatever we are designing, it has some factor of safety. So people do not understand that this factor of safety is nothing but factor of uncertainties, because many things we are not considering in design. So that is why these numbers have come. And also because the structure has to live 80, 90 years life, and with age, some aging effect will be there and some loss of capacity would be there. So we need to have some additional capacity at the time of new construction. So that is the thing where we have to keep in our mindset that whatever IS code is giving, it is the bare minimum. We do not have extra margins. And if we can do something better than that, we should attempt that. Maybe in terms of quality, maybe in terms of some better systems. And for the, as Mr. Jain rightly said that now because of the changed Indian standards, base share is going to be increased. It has already increased with 2016 code in terms of 2002, and then now it will further increase. Now, conventionally, if I'm saying then probably new buildings we can design with the conventional system, but if we are seeing the existing built environment, we will have to find out the innovative ways to retrofit it to match the requirements. Maybe some energy dissipation devices, maybe some improvement in the structural system, maybe some other innovative things which will come up. So we all engineers have to think about that how we can save our existing built environment with better systems, better technologies, and probably some innovations.
Thank you, sir. All of you touch based on one of the important aspects of capacity building, With this, this is my last questions, and after this we open to the audience. In the room currently, we also recently organized one of the workshops with repair, rehabilitation and retrofitting under the leadership of Pradeep sir a month back. And today we are also talking about the structural strengthening aspect. So in this platform, we all have engineers. Some graduate engineers will have 30% understanding on the topic, and others will have 100% understanding, right, with experience. But the buildings are not necessarily occupied by the civil engineers. So there is also a mix of people. So do we have any means to really bring the level of awareness? I know it's a broad topic, but can something be done in this regard very consciously? And it's an open question to all four of you. Please feel.
I think NDMA is already doing lots of work in this post Bhuj earthquake. They came out with very small booklets on this awareness purpose only. And in fact, it was going around very popularly in WhatsApp also, those small leaflets. So yes, that is helping us people a lot, no doubt in it.
Yeah, there are some attempts from the Indian Association of Structural Engineers also that some programs are coming and they are having their own booklets, and a lot of initiatives are being taken at different appropriate levels. But one suggestion I have been giving to many organizations and associations also, that we should have some seminar conferences like this for the common people also. And in this line, I in my organization have done this kind of public awareness program in July. And I would like that this kind of program should happen all over the country with all common people, so that they should be made aware if there is a spalling, if there is a reinforcement corrosion process or some other deterioration distress is visible. They should not just ignore it, and they should reach to the appropriate people.
Basically, this education has to reach to the childs also. Like the schools are also conducting a lot of programs where they conduct mock drill in terms of seismic event. The people are kind of understanding at that level also that what is the importance of this thing. So that is the area where also we need to focus on.
Yeah, so my fellow panelists have already talked about the need for educating the common non-technical persons, not necessarily from the field of civil engineering, but I'll step back and talk about the capacity building that we were dwelling upon. There have been some instances where, what you have rightly mentioned, there are some engineers who have about 10% of understanding, and on the other hand, there are some others who have 100% of understanding. When we receive some requests at IIT Delhi that some structures require some structural audit, for example, or it requires certain condition assessment, typically the letter always say that structural stability. And all those letters are coming from engineers. So as an engineer, we should be aware that stability is a very technical term in structural engineering. We cannot use that so loosely. So that is where awareness is required even in the engineers, that what kind of terminology should be used. And the efforts of all these code committees have again led to a nice document on strengthening, retrofitting, what is difference between them. At IIT Delhi, we have one full one-semester course on strengthening, retrofitting, rehabilitation, but it is an elective. Now, we tried to offer it number of times, there were no takers. There are some other courses being taken, but not this course. So, there were no students who have ever taken this course. And of course, it's an elective, so we cannot force any student to take it. So, that is the other part of the story as was being mentioned. Also, we were talking about two things which is again related to the public awareness. One very, very crucial that Pradeepji has highlighted, the false ceiling. At any forum that I get an opportunity, I always say that as an engineer, we should say no to false ceiling. Absolute no. Okay? False ceiling is basically a way to hide the things. And to me, it is not required. We can give a very, very nice aesthetic treatment to our ceilings. That is very easily possible. Whatever aesthetics that you are able to achieve through false ceiling, we can do that simply by using ceiling itself as whatever aesthetic that we could give. That is one. Second is the wall cladding. Okay? There are some wall claddings applied in schools where children are there, they are not familiar that typically they should not walk near the wall. And we have very, very high, massive stone cladding applied, and they are just falling off. They simply use a cement slurry to paste it. And over a period of time, just with shrinkage cracks development, it just falls down. And unfortunately, there have been some mishaps because of that. So again, as an engineer, we should absolutely say no to wall cladding. You can give very nice aesthetic treatments to walls. So in any unfortunate circumstances, failures because of false ceilings and wall panels should not occur.
Yeah, I would just like to add on this, a very pertinent point Dr. Masagar has told. The cladding part, in fact, I would, if I recall 25, 30 years back, there was a concept of having external facade to be a kind of permanent facade which required no maintenance, kind of grit wash plaster or stone cladding or something like that. And now, because we are into the structural audit for so many years and we see these special challenges that Dr. Masagar has just mentioned, that it is very, very risky because once because of some expansion contraction or some kind of thing, if a cladded stone comes out, it is a big risk for all the people who are around. And further, now because we are talking about audits also, if the building has to go for maintenance every 4 or 5 years or an audit every 4 or 5 years, it should be accessible and the structural element should be visible also. So my suggestion, as Dr. Masagar has so told, should be with the good quality finishes which do not restrict you to reach to the structural elements. That should be the considered for the, whether internal cladding or external whatever. We should have a system where we should be able to reach the structural elements.
And maybe with this, we open it to the audience to take few questions. Yeah, can we have, yes. But yeah, can we have the mic, please? One mic here and then one there. Excuse me.
Thank you for your nice presentation. Please allow me, sir. The lady has given to me the mic first. So he's my professor, so I need to take his permission, definitely. Okay. So my question may sound a bit tricky. I have two questions. One is related to the PT system. While I was taking lunch outside, as I was talking to one of the fellow engineer in the group. So I raised this point. So such an eminent panel here, I would like to raise it. So how we look at the PT system in Indian context, and I've seen there is a reluctance to use the PT system in the building. That's my first question. And when it comes to the seismic, people are very much concerned about the PT. Second question is, when we do the structure design, in the structure design, we can, make our structure such a way that we can optimize it, dividing it into two ways, some part as lateral system, another as gravity, correct? So when we come to the gravity system, our code, I think 13920, says that you need to check the deflection compatibility against R is equal to 1. So I am a bit, unhappy with this. Your main system, you are designing, if it is dual system or SMRF, or be it a tube inside tube or whatever, R is equal to 5, correct? And you are making the gravity system checking against R is equal to 1. If I put it theoretically, you are enhancing the force 5 times the actual earthquake that you have designed for. And then you're checking somebody which is actually not supposed to take part into the seismic action and making it stiffer or stronger compared to your main system. So it happens to be that I was serving out of India for some time, and there I haven't seen such a practice. And it is beautifully utilized when it comes to the use of these two systems. So these are two of my questions, if you guys can put some light on this. And definitely retrofitting, a very good effort by Hilti, a good exercise from good workshop since the morning. Thank you for your time, and much appreciations to Hilti.
Thank you. the question it was to address to whom?
To the panel.
Okay, so.
Please allow me to start. Yeah. I'll take the second question first, very quickly. You mentioned about two designs. One is the seismic and other is the gravity based, and for seismic we take R equals to 5 and R equals to 1. The simple reason for doing that so is, in case of seismic, we would like to utilize the inelastic capacity of the structural members. In case of gravity loads, we don't want to use that. We want that serviceability conditions are fulfilled, and thereby we take R equals to 1. There is another statement I would like to give this so that the concept is very clear. R, which is the response reduction factor, is equivalent to damage in the structure. Okay,
Sir, I'll
R
just stop
is
you.
damage in the
I'll take a
structure.
leave.
Yeah, I'll just.
I'm just leaving.
Yeah. So the damage, we do allow damage consciously in seismic designs, and in gravity design we do not want damage in the structure. That's the reason we take different R values. Thank you.
Yeah, right. So should I answer your first question also about PT slab systems you are talking about? Well, pre-stressing, when we talk about, generally it was earlier considered for the large span systems only, for control of deflection and all. Gradually it has entered into the building systems, where now it is being popularly used for the large span buildings. And we are not only doing slabs PT, but beams also being considered for the pre-stressing or post-tensioning, what we call. When we talk about seismic systems, now first of all, the main thing is that we are not very happy with the performance of the flat slab systems, right? So because if we have to go for flat slab system, because we don't have stiffnesses for the lateral systems for the columns to take the stresses, we have in our codes restricted the span deflection limits. Now H by the limit shall be H by 1000. So that is the thing where the deflection of the building is a bit restricted if we have to go for flat slab system. So generally the PT is being considered for the flat slab system. Now if we are going for beams with slab system, and in that if we want to take advantage of PT in the slabs, I do not see any issue. We can definitely take advantage of the pre-stressing in the slab, but the lateral the system for the lateral stability of the building should be with the beam column system. Now the further challenge comes when we have beam, but the beam depth is reduced because of some architectural reasons. Now we want to PT the beams also. Now if we are going with PT beams and PT slabs, the challenges are many. Now, I do not say that it is not feasible to design in high earthquake, but then for this kind of situation, the engineer should have in-depth understanding about how the earthquake forces will be dealt with and how the system will take the deflections, deformations, which will be there during the earthquake. Because you know, when we are taking R is equal to 5, we are going into the non-linear zone, inelastic range. During that situation, how the PT system would work, for that very special engineering is required, so that is why we are discouraging that.
Yeah, my point is that I appreciate that you brought up this way, and it's a very nice answer, but at the same time, shall we not adopt an hybrid in between the PT and the seismic? Like we only consider the PT system for the gravity, and suppose whatever the seismic forces that we are getting, because eventually we have to please our bosses. Our bosses are the architects or the owners of the company. They have zero clue of the structure or a very limited clue of structural engineering. So if we adopt a mediocre approach in which for the gravity, yes, we take the PT system and all. For the lateral system, we provide the steel, we perform all the checks, and we perform all the necessary deflection checks or whatever the checks. Because for slab, I'm not considering this thing. My point was towards the beam only, and a scenario where we are dealing with the big span cantilevers.
Yeah, I already told you that there is no challenge in using this if our lateral system is adequately designed. The only thing is that it should be properly designed and properly executed also, because in one project what we could see during our audit, probably the design was good, everything was good, but building was rendered to be unusable just because the PT failed. large span building it was, and because the grouting was probably not done properly, because when we later on took this building for the retrofitting systems, and we found that the sheathing inside was no grout, and the bars did not acted as they were supposed to be acting. So ultimately it is about the skill of the design as well as execution, and with that there should not be any challenge.
So otherwise adopting this approach in which we are using PTE only for the gravity and the rebarring providing extra
yes,
for
for
this,
later systems you should have the complete requirement fulfilled as per ICT 19.
Fair enough, thanks.
Just to give you a little bit more comfort, that this is exactly we are using for most of the data center buildings where the height is a constraint. So most of the data center building where we are providing the PT beams along with the PT slabs also, and exact same approach we are using, that we are using the normal reinforcement for necessary checks. It's a hybrid of two. Yeah.
Maybe we take the next question from Dulal sir, and we also had Sharma sir asking a question. So we take the questions one after the other. Bhaumik sir is